This cryptography project video will cover all the process of encrypting and decrypting matrices with an encoding metric of 5 times 5. Firstly, we started off with the brainstorming for a creative sentence ready to be encoded. Then we define a different number for each alphabeted symbols. We also define full encoding matrices of 5 times 5 for each member. At this point, they are not yet to be confirmed that it is usable, but will be by the following calculation.
Before we start, let's see what is determinant. The determinant is a scalar value that can characterize some properties of the matrix, such as the number of solutions of linear equations and whether the matrix is invertible or not. If the determinant is 0, the matrix will be not invertible, or we can also call it a singular matrix. So, if the determinant is not 0, it will be invertible, which can also be called a non-singular matrix. For this work, we can only use the encryption matrix that has the determinant of 1. So, we need to calculate the determinant of every encryption matrices we created to check if we can use it or not. There are many methods for finding the determinant, but my group used 2 methods. The first one is Gaussian elimination, which is a method that we need to add multiples of one row to the others until the row echelon form is obtained. Note that a row echelon form is a form that has number 1 lie in the main diagonal, which is from the top left corner to the bottom right. Then the product of the main diagonal will be the determinant. The second one is the triangular matrix method. In this method, we need to add multiples of one row to the others until all the entries below the main diagonal are zeros. This is called an upper triangular matrix form. Then, the determinant will be the product of the main diagonal.
Inverse of the encoding matrix is in order to create a decoding matrix. The decoding matrix will be used to transform the encoded matrix back to its uncoded form. Inverse matrix can be found in many ways, but we're using Gaussian elimination, which is an algorithm that can be used to solve systems of linear equations and to find the inverse of any invertible matrix. The process is similar to Gaussian elimination but continue the reductions until the reduced row echelon form is obtained. This form also looks similar to the row echelon form, but with every other entry in the column that has a leading entry of 1 equal to 0. It seems to be the best and the quickest way for finding inverse matrix. First, set the encoding matrix next to the identity matrix. The main idea of this process is to make the encoding matrix become an identity matrix. Second, apply the same operation as the one for finding the determinant to both matrices. Third, continue dividing the matrix with the same number of the leading entry of each row to that row in order to obtain a row echelon form. Fourth, multiply the leading entry of 1 with the number of each entry above it and an opposite sign from each number. Then add the product to each row accordingly to eliminate those entries above each leading entry of 1, making them equal to 0. Fifth, the steps will be repeated until all entries above and below the main diagonal have a value of 0, which is a reduced row echelon form. After the encoding matrix is in the reduced row echelon form, or in another word, identity matrix, the identity matrix in the beginning automatically become an inverse of the encoding matrix, which is a decoding matrix. The resulting inverse matrix can be checked whether it is accurate or not in the next step.
In this project, the encoded matrix is an 8 by 5 matrix. Second, we define an encoding matrix which is a 5 by 5 matrix with a determinant of 1. Then multiply the encoded matrix with the encoding matrix to get an encoded matrix. In order to do a multiplication of 2 matrices, we have to follow the following steps. Step 1. Make sure that the number of columns in the first matrix equals the number of rows in the second matrix. In our case, we multiply the 8 by 5 matrix with a 5 by 5 matrix so it can be done. Step 2. Multiply the elements of each row of the first matrix by the elements of each column in the second matrix. Step 3. Add the products. There is one interesting point about matrix multiplication. If we multiply any square matrix with an identity matrix of the same order, the result will be the same as the original matrix. An identity matrix is a square matrix of any order in which all of the main diagonal elements are equal to 1, while the rest of the matrix elements are equal to 0. For the next step, we do another multiplication by multiplying the encoded matrix with the inverse matrix of the encoding matrix. And the result is we get our original uncoded matrix.
The mistakes that we have while making this project is mostly the calculation part, because when we type in the wrong number in the calculator, it will change the result and affect the whole calculation. The solution of this problem is to calculate on the Google Sheet and recheck it again with the calculator. With this solution, not only we will get the more precise result, but also don't have to waste the time to fix the mistakes.